Yes. So, as Mehmet said, what we will do is write this 4-point stencil, 5-point stencil, and now this stencil only needs to run for the green portion of this image that is inside. In blue, we have the boundaries, and inside the green region is what we call the core domain. So, just to introduce the naming we will use in the code, this is the core inside, and the boundaries are also referred to as the halo. So, this is because these boundaries, aside from being the physical boundary conditions, are also areas of that we do not touch with our core computation. And the boundary conditions are set by another function which we will not touch. But all we need to do is go over one by one all of the core domain or in parallel and apply this 5-point stencil. So let's see how we can do that. Let's go into our next hands-on, the heat equation stencil. So another thing that I want to explain is for the boundaries when we were filling in the initial condition, we were really touching the whole buffer. So this meant also filling in these regions in blue, this region in green. We really went through all of the buffer. But now we only need to go over the core. So what we do is we define an alternative work division. Earlier, we were using a work division which was mapping the whole domain to threads. Now we only have a work division which will launch as many threads in a grid as the central core. This is important. We will only have as many threads as the green region. So let's just dive right in and start writing. So inside to heat equation stencil, you will find what you need to do. The README says, okay, I need to edit the stencil kernel and do an element-wise multiplication and sum of the stencil corresponding 5 points. Okay, let's do it. Inside the stencil kernel. So again, this is a kernel. This is what will be running on our GPU or accelerator. Maybe it's a CPU. Already we have the grid thread index. We know this is useful. We have also defined some other constants, or x or y. And down here, we have the actual formula that we would like to implement. So let's get to it. What would I really like to write? Somehow I want to say, okay, give me the buffer where I want to update this. So as Mohammed already pointed out, we use a solution with 2 buffers. This allows us to store all the current data in one buffer and then just only read from this one and update the next buffer. This allows you to read in parallel, because if you start modifying the same buffer, then you need to be careful of how you synchronize it. So we use double buffering. So uNextBuff is the buffer I want to update, and I am reading from the current buff. So let's see, what do I want to do? I want to say, okay, uNextBuff at position whatever, the center. Obviously, what I'm writing is not valid C++. But this is what I would like to write as pseudocode. So in the next buff, I would like to update the center. And what would I like to use to do it? I would like to use the current buffer, center multiplied by this factor, which I get from physics, Physics is very important, everyone. It's why we are here, yes. And then we will, I want to get the position on the left, the position on the right, multiply that by certain factors, and so on. So the first question I have is, okay, what is this center? So let's try to figure this out. In our initialization buffer, what we were doing is we had the full buffer and each point in the buffer corresponded to a single thread. Now we only have enough threads to go over the core region. Again, this green portion is the core region inside, and one cell on the outside is the halo or the boundary region. So if I say get me the grid thread index 0, I want that to point to this element in the buffer. 0, 0 should point to element 1, 1 in my buffer. So given that I have already spoken the solution in words, can someone tell me what center should be? My center is grid thread index, is it? Is this correct? Do I need to do something else? So
it depends on your work.
So you're right. My work division is only creating threads corresponding to the core region.
Where's the index 0, 0 of? I mean, is it just the number of threads that I find here?
Yes, exactly. So the point is, what you find out is only the number of threads. And the indexing always starts from 0. When you are looking at the threads, the indexing is always from 0, 0. So when you call get idx grid threads, it will start from 0, 0, and it will go up to the number of threads you have defined in your work division.
And our data includes boundary conditions.
Yes, but so you only have threads corresponding to the green one, but our buffer, our actual data, has data corresponding to also the boundaries. So again,
I have to shift my index.
You need to shift your index, exactly. And you can do that by simply defining a alpaca vector and So I shift it by one cell because, well, my image says that there is one cell, so I do it. But the correct way to do it is by using this halo size. This is something we define and pass into the function. You don't have to worry about this right now. But what you need to do is just simply add the halo size and there you are. That is your center. Very well. Now you have your center. What would be the left or the right? All you need to do is move in the corresponding direction, left, right, up or down from your center. The good thing about having this halo region, and this is quite common in such domain decomposition schemes, is that you do your computation on a core region and then you have some boundaries or halos which are, say, commonly given by your physical setup, or maybe you make these artificially. And this way you don't have to worry about going out of range. So if, for example, I wanted to update this cell in particular, and I wanted to look at the cell above it, I would go out of range of my memory, and this would give me a seg fault, which is not nice. Everyone hates seg faults. So what you do is stay inside the halo, have a buffer halo region, and then access that index safely. So I will write what my left is. Oh, this is simply center plus alpaca vector. So, so over here I'm using an alpaca vector, and again, most of the things which alpaca returns, for example, using getIDX, or in most places actually, is a vector. And a vector is actually more like a standard array, if you're familiar with it. So it has a fixed size. So it's not a vector which can be infinitely extended. It's very similar to a standard array with a fixed number of elements. And I would just do -1, 0. Is this correct? So, no, it is not correct. Who can tell me what is wrong? I already saw you.
Yeah, like X and Y.
Yes, absolutely. So the X and Y are flipped, just to keep you on your toes. This is important. Alpaca indexes the fast moving. Yes.
I have a question to the line prior actually to the center
Mm-hmm.
definition. I'm not sure if I get what the halo size is. If it's really like a vector of the size 1, 1. This for me makes sense in the upper left corner, but if you're on the lower right corner, would you like blend out of this?
Yes. So the question is, I am doing grid thread index plus halo size, which is a vector of 1, 1, 2D vector. And if I am at the bottom right region, so over here, and I add 1, 1, won't I go out? Yes, you would absolutely go out. But the cool thing is that our work division is only going over the green region. We only spawn as many threads as the green region. And so if, for example, I was not adding the halo size, I would go over this region. Is this clear?
This is the work division.
Yes.
We are just moving. This is.
No, you can leave it.
Yeah, we are moving the work division here.
Yes, so you're right. If we were going over dangerous elements, it would be. But thanks to how we define our domain, we never touch boundary elements at all. Okay, we do the same for right. Can you read the question from the start, please?
As always. The question is about vector definition. Why template arguments are not used? In vector definition, we can use the size as a type here, and IDX, assuming that these are defined, and tdim and IDX. Tdim is actually 2 as a type because it's going to be a 2-element 1D array, 2-element array. Therefore, tdim is 2. IDX is the index type, which could be int or short int or long int. And but we don't need to use those types here because they will be deduced from the arguments. Yeah.
Thank you. So what I want to do is Rx left, right. What I'm doing is very dangerous and can lead to copy paste errors. So please be vigilant. So again, this is super nice. This is what I want to write, but I can't really access the buffer like this. And we already learned in our initialize buffer example that the way to access an index given the buffer is using get element pointer and then dereferencing it. So this is what I need to do. So I will say, okay, get element pointer of the next buffer at index center. And the pitch is, you can see we have passed two different pitches. So I have two different buffers, and even though the buffers are same in this case, and they probably share the same pitch, just to be safe, because it might not always be the case, we pass two different pitches. So we use the pitch for the next buffer to get the element in the next buffer. This is how you do it. Similarly, for current buffer, I will and use the correct pitch. Sorry about the horrible formatting. Okay. Center, left, right, up and down. And that should be it. So this is my 5-point stencil. And now we will try to execute it. So again, go to the correct directory, of course, heat equation stencil, build, the build instructions are same all the time. I enable the sequential backend. I enable the HIP backend. Let's see if it compiles. Oh no, it does not compile.
You're writing C++, it should not compile.
Yes.
You have to have parentheses around the vector in the indices, because here it thinks like it uses a different constructor, not using.
Ah. You think so?
IDX,
Oh, yeah.
I think, and you need the parentheses and the curly braces.
No, the problem is
No.
it's using the wrong type. So
Yeah.
it is also the 0 is an int, another unsigned long int which is required for the EDC.
And LU.
yeah.
Yeah. And LU, if it is long.
Is it a long int? Are you sure?
Yeah.
Wait a moment, I
But
copy it.
in braces cannot be
Yeah,
signed.
unsigned long. No, wait, unsigned int. Sorry.
Oh, then.
No, no, no.
I mean, I would make sure that they use the right structure adaptations.
Oh, yes, unsigned group.
Are we sure this is the error? Let's see. So this is, I guess, also something important for everyone to see. This is what happens when you get errors with template arguments. Invalid operands to binary expression. Okay.
Yeah, the left hand is unsigned int. You see it in the error message.
Uh-huh.
This is unsigned int. Yes, because your accelerator has the index schema unsigned int.
You are right. I can work around this.
Putting minus? No. Plus? I would suggest to define simply the vec type.
Yeah.
Use it from set
Yeah.
up. Use it as constructor type. Oh, yeah. Das ist halt eine Value.
But IDX type is already unsigned. Wow.
Until your last changes in
Uh-huh, you're right.
try the using for vec.
Because the
Using, we can use this. Let me.
Yeah. And actually it's using for the but yeah.
Let's see.
You can that's control.
Nee, das ist ja auch nicht die Typ, das ist eine weitere Version. Dann hast du die Minus-Operation. Das kannst du nicht.
Then we can do all of them week one.
Ja. So, dadurch,
Yes?
Klaus said instead of center plus something, say center minus something, and then define the vector as 0.1.
Did you use the correct operator, the correct type?
Yes. But actually no. Because
You can.
no, because the problem is t index, correct? Not t dim.
Anyways, it's based on the types are unsigned. That's perfectly fine to
Check
have a minus operation to unsigned.
Just compose it.
All right.
The web line 55.
Yes.
Yeah. There's a question about in the end, will we be able to access the complete solution of hands-ons?
Yes. So the question is, where can you find the complete solutions of the hands-on sessions? So for every hands-on session, you can find the solution in the next hands-on session. So everything is filled and it remains filled for the next step. Obviously, you might want to see the full code at some point, and you can find those in folders called recap. So for example, here, recap after chunking is the state of the code after hands-on 5, and it's a working example. So at any point, if you're stuck, you can just go into the next step, take a look, things should work. So we tried running and execution results are correct. So what is happening is we run a full heat equation simulation. Obviously, you don't see most of it. We only see the kernel that we are writing right now. But if you have written the kernel correctly, the simulation will run and you should see some images. So, for example, this one or this one. And you will see that the circle is growing fainter. So our heat equation example is, so just to be clear, these images are in the build folder, and the postfix of the heat image is the time step at which you are looking at it. And as you keep on going, it gets fainter because the initial Gaussian heat distribution dissipates. I think it's a Gaussian, I'm not 100% sure. I think it's a Gaussian with some sine modes. Anyway, physics is important, but yeah. So if everything runs correctly, this is what you will see.
Maybe we can have a break
Maybe after the presentation.
after the presentation.
Or maybe in
The
between.
presentation is quite a long presentation.
So maybe we'll split it again. Yes.
Yeah, there is a bit of question. What is the type of TIDX? Is it inside int or is it int?
So
it should be defined in the main code. Yeah, at the beginning. Yeah, it is.
Because we are, I mean, the point is that we are assigning a vector with the value 0, -1. And it's inside int.
yes, Brian, do you?
The answer works to complement. It essentially, the unsigned integer wraps around the highest number -1 if you inside -1. And essentially, it still works as you think it should. Just the minus, if you look at the exact value of -1 initialized value, it will not be what you expect it to be, but the result of the operation is what you expect.
But why do we use here for IDX UI32T? Why not int 32?
This is also completely possible, and
Because then it would be less happy. Because the first index is probably a flag, I can imagine, in the center, but the following indices are not fake int, I mean, are fake of int.
The question in the audience is why we are not defining already, is it marked the line? Why we not define here the index already as integer? So okay, here it is possible. So we use this index definition. This is on a host file, and this will also be used later on for defining how the accelerator is working. So you have in Alpaca a lot of freedom. So you can do many things wrong, but the compiler will say you very often that it is wrong, and in very complicated form it will say it to you. And what we choose here is now what is our index type for wherever we use it, and we use it later on for defining a work division. This means then if you use it for defining a work division, this is unsigned integer, that all your thread indices will be unsigned integers. You're also free to use integer at this point, even if you will never have negative threads indices, it makes no sense. And you can, independent of defining the index type for your accelerator or for your work divisions, you can also define what should be the index type of your buffers. Because think about if you use here an unsigned int, we can only have a buffer with 4 giga elements. Because then we will wrap around because of the 32-bit issue that we cannot address anymore. So if we come to later sessions, maybe or to the pick on GPU session on the third day, we maybe talk about optimizations, and then the optimization coming maybe hand in hand that you define index type for your accelerator with 32-bit, because you know you will never have more than 4 giga threads, but your memory is more than 2 gigabyte or 4 gigabyte, and maybe then for the memory indices you use size T, but later on you calculate it with indices from the thread, and then you like to calculate an address offset of your buffer. The type must always be fit. So I think our vectors in Alpaca are not doing implicit conversions. So therefore you need to always explicit convert. And here we choose the unsigned integer because for thread indices it does not make sense to have negative indices. But in principle you could also simply change here to int, and then you do not have the trouble we discovered already at the moment in this kernel.
Yeah, or what would be, because here the problem is that we are doing this plus vector of 0, -1, and if we could do minus vector of 0, 1, there would be, we could still use units.
Yes. This is possible because C++ is defining that it's Zweierkomplement in German. What is the English?
Two's complement.
Yeah, that the two's complement must be fulfilled in C++. Therefore, yes, you can also say minus.
It was not compiled, maybe because of the previous problem. Maybe they should try to do minus.
Let me come around.
Maybe let's try to. Yeah, yeah.
So for everyone who is not familiar with C++ arrows, the typical case if you use templates, and Alpaca using a lot of templates, and modern C++ using also a lot of templates, and if we not use C++ 20, where maybe the error messages are nicer because of a way to describe a little bit dependencies, so you can define concepts, then always read the first arrow. Ignore everything behind, scroll always up to the first arrow and look to the first arrow, because all other could be follow-up arrows, and maybe they are really saying nothing because they only be shown up because a type was not correctly deducted in the beginning. So always scroll up to the first arrow and solve always the first arrow, and also warnings are arrows. Think about it. Because very often the warnings get ignored, but they are very often useful. You should never have warnings in your compilation.
Yes, but the problem with the arrow you mentioned is this is not the value. Here, like a zero minus this is an integer. If you write zero value and also minus one, then it will be an answer.
I have the same problem.
Yes, for all of them. Yes. Or you did what they do, they explicitly say what is vector. Oh, you have vector one. Now use vector one. There are some solution you could use what they define on vector one, or you could try this one solution.
Yeah, getting words.
Do you run on CPU? Yeah. That really took a while.
To be honest.
Maybe it is one. Yes. Oh, I'm not sure if it's not doing one step or all steps. Is it doing one step or all steps?
All steps.
Okay, then it took maybe. Oh yeah, now it's finished. It was the CPU was quite slow. Very slow.
Oh yeah, function.
Yes. You can go now. I think also to the web interface. Do you show how to access the images?
Yes, via the web interface. It's inside the build folder. And you can just look at it inside VS Code.
And use this. You use Visual Studio Code.
Yes.
Yeah. You can, if you start this one, you can you need to set another version. There you go. One quarter now.
We haven't seen any other.
The previous session already open.
Yeah, well, I'm working on it.
Okay. Oh, right here.
Yes.
You said sometime we should not do something because we get a segmentation fault. So I'm getting a segmentation fault. So I guess. Sorry, I got it. To remove the contributor directly. It was looking with the head before, I'm not sure how large it is. If it was 2, then you might still get a 1 or go to warehousing equation. Yeah, remove the contributor again. You are already
After you open the vector, Visual Studio tool, do you know how to get that access to the code and then the portfolio cost?
Yeah.
Could you help them? You open now the Visual Studio code.
Yeah, but there it is already. It's in the grid directory or not?
Yes, no, it's
Yeah. No, okay. You part of the
Yeah.
this is going outside.
yeah. Now you have something to click on code. I need always to press enter, so it's
Yeah, weird.
there are other ways like this HFS to mount or putting on the laptop and then you can directly use the file mouse still to the data and some
I'm usually that's well, it's not a good habit, but I'm usually used to go to servers and work with them there, and then like for asking things like accesses.
Why do you still
Well,
then you have to do the file explore and
okay.
the faster scroll.
Okay. Well, I got what I wanted for now. Thank you.
It's pretty good.
Aber danach
It's not that it's not serious because of things that okay, well, I can, yeah.
So the one I
Why do you only have to do it for the download as well?
these are two different workarounds.
Okay, I see. Okay, I'll try that.
Are you done? Are the results correct?
Yes.
Pictures and
Validation says it's correct.
Woohoo! Okay.
alpaca experts now.
Yes, we have bright students. I like it. Yes, I think tomorrow I will get some sweets, and the person who finishes fastest will get a toffee. This is cool.
and what is it? I have begun.
Oh, that hurts. Okay, so till now we have been working inside alpaca kernels and looking at basically the code which will be accelerated by your GPU, CPU, whatever. but we haven't actually looked at how we get how do we execute this? How do we get these buffers that we are playing with? How do we get these indexes or pitches? And what goes into actually executing one of these? And that's what we look into next. But this will come after the coffee break. So for now, we will have a 15-minute pause and we will resume at 3:30 p.m. So 15:30 Central European time. So for people online, you can take a break and we will see you soon.
What other question? How many means dimension? How many
The number of dimensions of vector, do we not have it?
After the break. So now it's after the break.
Now it's all
Yeah.
Okay. I was running thinking that I was, okay.
Because you are not for No, but
I can also wire
you
it.
have double probability all the time, you can do it, but we have a
But
function.
it gives time and the user will understand what is.
Yes, yes, you need to write taking time and then.
Okay, we can improve it. Thank you, Klaus.
And we do not have a function to get the sum